Have you ever looked up at the night sky and felt a sense of wonder mixed with a little bit of unease? That feeling that there's so much more out there than we can possibly comprehend? Well, today we're diving headfirst into that feeling. We're going beyond the stars and planets we can see and venturing into the bizarre, mind-bending world of quantum physics. This isn't just about complex equations in labs. It's about peeling back the layers of reality itself. Quantum physics is our ticket to exploring the most unsettling and fascinating mysteries of the universe. So buckle up, because things are about to get weird. Let's start with something you probably have in your pocket right now: your smartphone. The technology that powers it, the transistors, the lasers, the microchips, is all built on the principles of quantum mechanics. It's a science that has fundamentally shaped our modern world. But here's the twist. The very scientists who developed it were deeply disturbed by what they found. Albert Einstein famously called one of its key concepts spooky action at a distance. So, what is it about this field that's so profoundly strange? It's the simple fact that when you zoom in on the universe, way down past atoms to the subatomic level, the rules of our everyday world completely break down. Imagine a particle that can be in multiple places at once. Not like it's quickly moving between spots, but it is literally in all those places simultaneously. This is called superposition. It's like spinning a coin. While it's in the air, it's both heads and tails at the same time. It's only when it lands, or in the quantum world, when we measure it, that it chooses a single state. This idea alone is baffling. It suggests that reality, at its most fundamental level, is a fuzzy cloud of probabilities until an observer comes along. This leads to a huge, unsettling question. Does the universe even exist in a definite state if no one is looking at it? Think about that for a second. It challenges our most basic understanding of what it means for something to be. Now, let's get to Einstein's spooky action at a distance, a phenomenon we now call quantum entanglement. Imagine you have two particles that are linked. Whatever happens to one instantly affects the other, no matter how far apart they are. If you measure one particle and find its spin is up, you will instantly know the other particle's spin is down. This connection is instantaneous, seemingly faster than the speed of light. They could be on opposite sides of the galaxy, and the link would still hold. This seems to violate one of the most fundamental rules of the universe. Nothing can travel faster than light. How can these particles communicate instantly across vast distances? Are they communicating at all, or is there some deeper, hidden connection woven into the fabric of reality that we don't understand? This is a mystery that continues to baffle physicists today. It's as if the universe has a secret, invisible network connecting its most fundamental pieces. Perhaps the most famous and perplexing experiment in all of quantum physics is the double-slit experiment. It's simple in concept, but profound in its implications. You shoot tiny particles, like electrons, at a screen with two narrow slits in it. Behind that screen is another screen that detects where the particles land. If you cover one slit, the electrons behave as you'd expect, like tiny billiard balls, creating a single band on the detector screen. Simple enough. But when you open both slits, things get bizarre. The electrons, even when sent one at a time, create an interference pattern, a series of multiple bonds, as if they were waves interfering with each other. It's as if each single electron passes through both slits at the same time, interferes with itself, and then lands on the screen. But here's where it gets truly unsettling. If you place a detector at the slits to see which one the electron actually goes through, the interference pattern vanishes. The moment you observe it, the electron stops acting like a wave and goes back to behaving like a particle, creating just two bands. It's as if the universe knows you're watching. The very act of observation changes the outcome. This suggests that consciousness, or at least the act of measurement, is not a passive observer of reality, but an active participant in creating it. This is the measurement problem, and it's one of the deepest philosophical and scientific puzzles we face. What does it mean for reality to change based on whether or not we look at it? These quantum mysteries aren't just abstract thought experiments. They have real implications for our understanding of the universe. Take the concept of the multiverse, or many worlds interpretation. One way to solve the measurement problem is to suggest that every time a quantum measurement is made, the universe splits. In one universe, the particle went through the left slit. In another, it went through the right. This means that every possible outcome of every quantum event happens in its own separate, parallel universe. This isn't just science fiction, it's a serious scientific hypothesis. If it's true, there are an infinite number of universes, an infinite number of yous who made different choices, living out different lives. It is a staggering thought that reduces our entire existence to just one branch on an infinitely branching tree of realities. Then there's the nature of space and time itself. Some theories, like loop quantum gravity, suggest that space isn't a smooth, continuous backdrop. Instead, it's made of tiny, indivisible atoms of space-time, woven together like a fabric. At this quantum level, our classical notions of space and time dissolve into a network of relationships. It suggests that the smooth, flowing reality we experience is just an illusion, an emergent property of a much stranger, pixelated reality underneath. Could it be that the universe is fundamentally digital? That all of reality is built from discrete bits of information? What all of this points to is that our intuitive, everyday understanding of the world is just a sliver of the whole picture. Quantum physics shows us a universe that is probabilistic, interconnected in spooky ways, and potentially reactive to our own consciousness. It's a universe where particles can be in two places at once, where observing something changes its nature, and where countless parallel realities might exist alongside our own. This can feel unsettling because it shatters our sense of a solid, predictable reality. It replaces certainty with probability, and solid objects with shimmering waves of potential. But this is also where the wonder comes in. These aren't just paradoxes meant to confuse us. They are clues. They are signposts pointing toward a deeper, more fundamental truth about the nature of existence. Scientists around the world are working tirelessly to unravel these mysteries, pushing the boundaries of what we know. From building quantum computers that harness the power of superposition to designing experiments that probe the nature of space-time, we are on the cusp of a new revolution in understanding. The unsettling nature of quantum mechanics isn't a flaw, it's an invitation. It's the universe challenging us to think bigger, to question our assumptions, and to embrace the profound mystery that lies at the heart of everything. The journey into the quantum realm is far from over. We've only just scratched the surface, but one thing is clear. The reality we inhabit is far stranger, more interconnected, and more mysterious than we ever could have imagined. So the next time you feel that sense of unease looking at the cosmos, remember that the biggest mysteries aren't just out there in the distant galaxies. They're right here in every particle that makes up you and the world around you. Thank you so much for joining me on this mind-bending journey today. If you enjoyed exploring the strange world of quantum physics, please hit that like button and subscribe for more deep dives into the mysteries of our universe. And don't forget to share your thoughts in the comments below. I'd love to hear what you think. Until next time, stay curious.